I am going to explain atomic spectrum, or simply called spectrum. The first question is why we call atomic spectrum. It is because the spectrum in artificial manner taken is obtained with the help of atoms, either by excitation or by absorption. We will see later on. Now see first point, a spectroscope. A spectroscope is very simple apparatus using which we can obtain a spectrum. It's called a spectroscope. It's very simple instrument, just like a telescope. Now, second is a spectrograph. A spectrograph is a combination of a camera with a reel and a spectroscope. That is, we can obtain a spectrum on a graphical manner, like on the paper of the photo, or simply we can say the photograph is obtained on photographic film. So this is one point. Now second is the classification of a spectrum. So a spectrum is of two types. First is emission spectrum and second is absorption spectrum. Emission spectrum is again of two types, continuous spectrum and line spectrum. Now I will explain first about the emission spectrum. So as name indicates, emission means when any substance emits some energy. For example, when we heat any substance, like firecracker, you might have seen different colors are obtained. White in case of Fulgari or the anar. Then similarly, red color is obtained in case of any light, or green color is also obtained. So they are basically the salts. The atoms on excitation gives to particular color. You might have seen whenever any vegetable is cooked, when what happens when it goes out of the vessel, then we get the yellow flame. So emission spectrum is obtained by the excitation. For example, we can take any candle. So when the candle burns, the light is obtained and light is passed through a slit. Slit is very simple. It is a plate with a hole, and the purpose is that it allows the light to come out in form of a fine beam. Then the light is passed through a prism, and then the prism gives the spectrum. So emission spectrum is obtained either by burning or by heating of a substance. On heating, the atoms are excited to higher energy level. Their energy becomes very high. They gives away the radiations or energies in a particular manner, particular frequency, particular wavelength. Then it is passed through a slit, then through prism or by a spectroscope, and here we get the spectrum. Here we get the spectrum. Now it is of two types, continuous spectrum and line spectrum. Now a spectrum is said to be continuous when there is no break, there is continuity one after other. Like I have said on the previous turn, with your all the seven colors, they overlap each other. There is continuity, or there is no breaking. There is complete overlapping. One color overlaps with the other color. Like say here there is, just I am going. So we see in the particular boxes all the colors are distinct, but between violet and indigo, here we cannot distinguish the two. here there is complete overlapping. So there is the overlapping and there is no break. Such a spectrum is called as continuous spectrum. This is one point. Now second is line spectrum. So line spectrum may be defined as when there is presence of bright lines in a normal spectrum. Bright lines in normal spectrum, then it is called as line spectrum. For example, in case of sodium lamp, you must be knowing vapor lamp, sodium vapor lamp, mercury vapor lamp. So for example, in case of sodium lamp or halogen bulb, if the light is passed through a spectroscope or a spectrometer, then in the yellow sodium atoms on excitation gives the yellow color. So in yellow light at 589 nanometer and 589.6 nanometer, two bright lines are obtained. So this is called as line spectrum. Now then next is the absorption spectrum. So as name indicates, absorption, so normal light or white light is passed through a solution or substance. Suppose we take this solution, suppose we have NaCl aqueous, and we pass light, normal light, ordinary light, and then the light comes out. So here in the NaCl aqueous solution, these particular frequencies are absorbed by NaCl, and when we pass through prism, then again here you get the spectrum, but at 589 nanometer and 589.6 nanometer, we have two dark lines. There are two dark lines in the normal spectrum, and this is called as absorption spectrum or discontinuous spectrum. So this is all about the spectrum.